Hey everybody, we are about to start our next chapter, and before we get started on the notes, I just want to give you kind of a big picture. So we're going to be learning about polynomials, polynomial functions, and specifically we're going to learn about graphing polynomial functions. And one of the key features of graphing is to find intercepts. So finding Y-intercepts, X-intercepts, we also call those roots sometimes. And so we're going to be learning techniques to do that. Now you already know about a couple of the basic polynomial functions. Linear functions are polynomial. So for example, if you had y equals 2x plus 1, notice that the x is to the first power. So linear functions have x to the first power as the highest degree. And then quadratic functions, which you studied quite a bit in Algebra 2, are also polynomial functions. So for example, y equals 2x squared plus x minus 7. So in this case, the highest exponent is 2, and any other exponents have to be whole numbers. So x to the first is there, and then you could imagine an invisible x to the 0 on there. So whole number exponents for polynomials. And what we're going to look at in this unit, not today, but after today, is cubic polynomial functions. Those would have degree 3. So the exponent would be 3, the highest one. Quartic, the highest exponent would be 4. And quintic, the highest exponent would be 5. So of course there are more. You could go up as high as you wanted, but these are the ones we will focus on in this unit. First, for today, we're going to review the most important things about quadratic functions that you learned in Algebra 2. So we're on notes number 16. And what I've done is just make a table, and the important topics are on the left side, and then we're going to put the general information in the middle, and then do an example on the right. So the first thing to know let me even back up one step and remind you that a quadratic function has the shape of a parabola. So if you recall from the day we did basic functions, we did y equals x squared. So that reminded you of a parabola. It's that U-shaped curve. But any quadratic function is going to be in the shape of a parabola, either opening up or opening down. Okay, and the way you spell parabola is P-A-R-A-B-O-L-A, parabola. So, the standard form of a quadratic function is f of x, or y, equals ax squared plus bx plus c. There are other forms, but we call that one standard form. So for example, if you see f of x equals negative 2x squared minus 3x plus 1, that is a quadratic function. How do you know if it opens up or down? So if you think about your transformations that we talked about in the last chapter, you know that if you multiply the leading term by a negative, it reflects it across the x-axis. So if that number a in our equation there, whatever that happens to be, if that is a positive, it opens up. And if that is a negative, it opens down. So looking at our example, because the leading coefficient is negative 2 and it's a negative number, this parabola is going to open down. How do you find the y-intercept? Well, the answer to that question is the same no matter what kind of function you're talking about. You always plug in 0 for x if you want to find the y-intercept. So we let x equal 0 and solve for y. And then give your answer as an ordered pair. Okay, so in our example, if x equals 0, we have negative 2 times 0 squared minus 3 times 0 plus 1. We just get 1. So the y-intercept is the point 0, 1. Now in general, every time you put 0 in for x, the only thing you're going to have left is c. So you could say that in general, the y-intercept is the point 0, c. How do you find the vertex? if you're looking at a parabola, the vertex would be that point that's either at a minimum there, or if it opens down at a maximum there. How do you find it? Now, since this lesson is a review, I'm not going into all the details about deriving these things. I'm just reminding you things we learned from last year. So we learned that if you use the opposite of b over 2a, it will give you the x-coordinate of the vertex. Once you have the x-coordinate of the vertex, plug it into your function to get the y-coordinate. So let's take a look at our example. The opposite of b over 2a would be positive 3 over negative 4. So that's negative 3/4. That's the x-coordinate of the vertex. Now to get the y-coordinate of the vertex, we're going to put that into our function. So we have negative 2 times negative 3/4 squared minus 3 times negative 3/4 plus 1. And that's going to give you 17/8. So let me show you an easy way to do that on your calculator, just in case you're not familiar with how to do fraction things on your calculator. So first of all, we can just type it in on the home screen, negative 2 times negative 3/4 squared minus 3 times negative 3/4. Notice I'm using the negative button, not the minus button when I need a negative, plus 1. Okay, well that gives me the decimal value, 2.125. If I want to change that to a fraction, all I have to do is press the math button, and then the first choice is change to fraction, so press that, and then press enter. And it will give you the improper fraction form of your answer. So this is also handy if you had a fraction that you needed to reduce. Like let's say we had 500 over, 45, and you wanted to reduce that. You can type it in, then you can press math, change to fraction, enter, and it reduces the fraction for you. So using that fraction button can really save you a little bit of time. Okay, so we got the y-coordinate to be 17/8. So that means that the vertex is the point negative 3/4, comma 17/8. The next question is, how do you find the axis of symmetry? So if you think about a parabola, it has symmetry. There's a line of symmetry that goes right through the vertex. It's a vertical line. So because it goes right through the vertex, then whatever the x-coordinate of that vertex is will tell you where the line of symmetry is. So all you have to do, remember a vertical line has equation x equals a number. You just have x equals the opposite of b over 2a, and that's your line of symmetry. That's the axis of symmetry. Sometimes we say AOS, axis of symmetry. So for the example we're doing, we already know that the opposite of b over 2a is negative 3/4. So the axis of symmetry is x equals negative 3/4. How do you find the roots, otherwise known as x-intercepts? And I'll get a little bit more specific about that vocabulary as we go into this unit, but for today, let's just casually assume that roots means x-intercepts. So x-intercepts are points where the y value is 0. These are points on the x-axis. So what you need to do is put 0 into your function where the f of x is. So you would have 0 equals ax squared plus bx plus c, and then you would solve for x. And if you remember, in one of the previous units we reviewed the 4 methods for solving a quadratic equation. You would use factoring if you could, or you would use square rooting if you could. And if neither of those work, or you just don't feel like using those, you can use completing the square or the quadratic formula. Completing the square always works, and the quadratic formula always works. Once you find your x-intercepts, I do want you to put them in ordered pairs. And if those numbers turn out to not be real numbers, then they are not x-intercepts. They wouldn't be graphed. So only real roots are x-intercepts. So if you do the quadratic formula and you get answers like 5 plus or minus 2i, well, those are not x-intercepts if they're imaginary. So let's find the x-intercepts for our example. We'll take our function, negative 2x squared minus 3x plus 1, set it equal to 0. Now, I don't think this one is factorable, so I'm going to use the quadratic formula. And remember, in the quadratic formula, the first part is the opposite of b over 2a. And we already got the opposite of b over 2a earlier in the problem. That's negative 3/4. And then for the rest of the quadratic formula, we have plus or minus the square root of b squared minus 4ac over 2a. And this simplifies to be negative 3/4 plus or minus the square root of 17 over negative 4. Now, I'm going to write that as negative 3/4 plus or minus the square root of 17 over 4. And when you see that, you might think, uh-oh, she made a mistake. She forgot her negative. But actually, if you think about it, if you add a negative, you get a negative. If you subtract a negative, you get a positive. So plus or minus a negative is going to be no different than plus or minus a positive. So we can eliminate that extra negative sign. Now, writing these answers as ordered pairs, we have negative 3/4 plus square root 17 over 4, comma 0. And we have negative 3/4 minus square root 17 over 4, comma 0. Okay, we have a couple more questions here. Does it have a maximum or a minimum value? So this is not a yes or no question. This is, which one is it? Is it a maximum? Is it a minimum? Well, it depends on which way the parabola opens. If the parabola opens down, the vertex is a maximum. The y-coordinate of the vertex is a maximum. If the parabola opens up, then the vertex is a minimum. It's always the y-coordinate. So if we look at the next question, what is the minimum or maximum value? It's going to be the y-coordinate of the vertex. Okay, so for our example, because our parabola opens down, we had a negative leading coefficient, the vertex is a maximum. So this function has a maximum. What is the maximum for our example? Well, what was the y-coordinate of the vertex? It was 17/8. So what we're saying is that's the highest value, the highest y value that graph will reach. If you were to graph it, the highest point is 17/8. That helps you find the range, because the range would be from negative infinity to 17/8. And the last thing I want to do with this problem is to use all that information to draw the graph. So we're going to sketch the graph of the function. Just a rough sketch. So the vertex was negative 3/4, 17/8, and 17/8 is 2 1/8. So because of that, I think I'm going to go with something like this for my scale. And the x-intercepts we found to be negative 3/4 plus or minus square root 17/4. But if you approximate those with a calculator, you get about 0.28 and negative 1.78. Okay, so let's go ahead and plot the vertex, negative 3/4, 2 1/8, right around here. And then plot the x-intercepts, 0.28, right around there, negative 1.78, right around there. And then I would recommend at least a couple more points if you're graphing a parabola to get the shape. So what we could do is use that y-intercept that we found earlier. Remember, the y-intercept was the point 0,1. So we'll plot that. And then think about how the axis of symmetry is at x equals -3/4, and we could reflect the point that was just plotted across to the other side. And then we'll just go ahead and make a smooth curve. Don't make it pointy, make it round. And there's our parabola. Whoops. Okay. So that's a review of the main ideas that we learned about quadratic functions from Algebra 2. And this is your assignment. We do have a couple of evens in there, so I'll make sure to write the answers to the evens on Canvas when I write the assignment. Thanks, everybody.